Okay, I've been doing some magnetism experiments from this book, The How and Why Wonder Book of Magnets and Magnetism. And I'm going to do now an experiment on demagnetization. Okay, I'm going to use the pause a little bit on this one. So we're going to be following this. How do you demagnetize a magnet? Okay, and the technique that we're going to use is by a candle. Okay, we're just going to read through this. It says, another way to demagnetize a magnet is to heat it. With a pair of pliers, grasp the needle you magnetized and hold it in a flame until it is red hot. Place it in an east-west direction and let it cool. Then try to pick up a paperclip with the needle. You will find that the needle has lost its magnetism. The heat caused the atoms of the needle to move about very rapidly, and in doing so, to disarrange themselves. A heated magnet loses its magnetism at a very definite temperature. This temperature is called the Curie point for its discoverer, Pierre Curie, a French scientist. Each magnetic material has its own Curie point. For iron, it is about 800 degrees. It says centigrade here, but actually, I think that should be Fahrenheit, okay? For nickel, about 350 degrees centigrade. So that's just something to check on. I didn't notice that until we were actually reading it, okay? Because I think I've read 800 Fahrenheit at in a different location, okay? When we say that a demagnetized material has lost its magnetism, we do not mean that the magnetism has gone out of the material or that the magnetism has been destroyed. Each atom and each electron is just as much a magnet as when the material was magnetized, but the tiny magnets are no longer lined up so as to produce one big magnet. Now that you know jarring and heating will result in demagnetizing, you should avoid dropping, pounding, or heating your magnets. Okay, so now what we're going to do is I'm going to set up to do this experiment, okay? And here it's only mentioned here. It's not actually set out as an experimental procedure, but that's what I'm going to do, okay? Okay, now what I'm going to use is the half of a bobby pin, okay? Because we did use that. We magnetized that in a previous experiment that we did. And so we should be able to demagnetize this by heating it, okay? And it says needle. We could use a needle, but I'm going to use, in this case, this half. First step is I'm going to magnetize it, okay? I'm going to take one of my strong bar magnets. I'm going to stroke it like this. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Okay, so about 32 times. I'm going to turn it around and go to the south side. You see, I'm putting it on the end of the magnet because that's where the field lines come out. And I want them to go from out of that and into the other material, and therefore, they will, once they go in the material, they actually run along its length. 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 28, 29, 30. Okay, so this should be magnetized. Okay, now let's just test. I'll see if I can pick up a paper clip with it. Okay, I can. I can't pick up 2. I can pick up 1. That gives you a relative idea of its strength. Okay, and doing an experiment like this, it depends on how you measure it. Okay, I'm measuring this as being a 1 paperclip strong. And when I heat it up and demagnetize it, it's not that the magnetism necessarily is going to go to 0, okay? It's just that it might be reduced. If it's reduced enough so that it can't pick up the paperclip, it might look in the experiment like now it's been demagnetized because before it could pick up a paper clip and afterwards it can't. But you have to consider that these things they're not always that simple, that black and white. Okay, so what I'm going to do now is I will heat it up and put it in the flame. And I'm going to use this candle because the book says to use a candle. I could use a torch, but I want to use things that are readily available. And I did this previously, and I want to do the same technique. Okay, I'm holding it with my anti-magnetic tweezers. I'm going to hold it in the middle. That way I can definitely get the ends. And I'm not sure if the ends are more important. Now, I want to hold it in the hottest part of the flame. You might have a hard time seeing this. So I did a little research, and I found out that the hottest part of the flame is actually above the flame. It's not even in the colored part. It's right above the colored part. Here's where it could, in theory, it may be possible to get it hot enough for the flame, for the bobby pin to glow red. Okay, but glowing red usually means you have to be in a dark room. And it's a dull red. Okay, and you may not achieve it because of cooling in the air or along the length of the bobby pin, or even into the tweezers, depending on where you're holding it. So the book said that it would glow red. I'm not really able to demonstrate that, but I'm essentially going to do the best that I can. So you see that I'm moving through here slowly with the idea that I'm demagnetizing it as I go. I'll probably take a couple minutes to do this. So here's where I will use the pause because I'm not going to, just hold it here the whole time. Okay, I'm back. I probably spent about 2 or 3 minutes going through this slowly. I'll just do it one more time while we're on the camera. You can obviously take a few extra minutes here just to be sure that you've gotten it, let's say, as hot as it's going to get in the flame. It's anyone's guess exactly how long that would be, okay? For me, I want to hold it several seconds over one particular spot before moving it again, primarily because I'm not, in a tremendous hurry, okay? Now, I should also mention that I'm doing it in an east-west direction, okay? The idea is that after the material is hot, if I was holding it in a north-south direction, it might actually get remagnetized according to the magnetic field of the Earth, okay? Now, that may not make it enough to pick up a paperclip, but the idea is we don't want to take a chance. So when we're doing this type of thing, we want to hold it north-south, so it's not influenced by the magnetic field of the Earth, because that's not what this particular experiment is about, okay? Now, I'm just going to let it cool down a little bit. I'm going to take out a new paperclip from this box, so it doesn't have any residual magnetism itself from the previous measurement, okay, just to be more careful. I'll put the two of them there just like I did before, and now I'll try to see. So I'm just touching it a little bit because I know now it's probably, okay, it's cool enough to handle, okay? And I will now test to see if I can pick up the paperclip. Okay. It does not seem to have enough magnetism to pick up the paperclip, okay? So does that mean that it has no magnetism at all? Well, probably. It might still have some residual magnetism, okay? If I did a very sensitive test, I might find that it still has magnetism in the sense of deflecting a compass needle, for example. But that wouldn't mean that it might not be less, okay? This one clearly demonstrates that it doesn't have enough to pick up the needle, the paperclip, even though it did beforehand. This is the way this particular one is written up in the book. The only difference between what I'm doing here and what's in the book is the fact that I'm using the bobby pin rather than the needle. Okay, that's the only difference. So in this case, heating it up has demagnetized it. Okay? Good. Okay, thank you. Now, I did read that the hottest part of a flame here can get as high as 1400 degrees Fahrenheit. 800 degrees Fahrenheit should be achievable. Okay. It didn't glow red, but it seemed to work. Okay.